Hi, this video will demonstrate how to find an inverse of a function. First, the definition of an inverse function. If a function is one-to-one, it has an inverse. Key here is that the function has to be one-to-one. For a definition of one-to-one and how to determine if something is one-to-one, please see that video. Alright, so once we've determined something is one-to-one, it has an inverse function, and we call that inverse function f negative 1. This is not f raised to the negative power. This is not equal to 1 over f to the 1. Alright? That is not the same thing. All we're using here is the notation f negative 1 to denote an inverse function. Okay? This is not an exponent. Alright? Anyway, by definition, an inverse function is if we take the composition of a function and its inverse. Here I've got f inverse composed of f of x. Then if I plug f of x into my inverse function, I will end up with x. And also, by the definition, it also has to hold true that if I take the inverse and plug it into f, I end up with x. So f composed of the inverse of x should equal x as well. There are three basic steps in finding an inverse. Step 1, is it one-to-one? And like we referred to in our video, first you graph it and use the horizontal line test. If the function is one-to-one, then we can go to step 2 and we can actually find the inverse. If the function is not one-to-one, we need to stop what we're doing because the inverse does not exist. It does not have an inverse function. Alright, so if we determine that the function is one-to-one, we then solve y equals f of x for x. Alright, and then the last step is we interchange x and y to get our inverse function. So now we'll go through an example to explain exactly what we mean by steps 2 and 3. Here I have two examples. In the first example, we are going to find the inverse of 3x minus 2. I know that this function is one-to-one because if I graph it, it's a straight line. So first of all, I've determined that it is one-to-one. Okay, so now we need to proceed to step 2. Step 2 says I need to solve y equals f of x, alright, for x. In other words, I'm going to solve y equals, in place of f of x, I'm going to put what my function is, which is 3x minus 2. Alright, and I want to solve for x. So I'm going to basically isolate x on one side. First, I'm going to add 2 to both sides. I get y plus 2 equals 3x. And now, to isolate my x, I'm going to divide both sides by 3. Okay, and I get y plus 2 over 3 is equal to x. The last step in finding an inverse is to then interchange x and y. So wherever I have a y, I'm going to replace it with x, and wherever I have an x, I'm going to replace it with y. So this becomes x plus 2 over 3 equals y. Alright, and actually now this is my inverse function. So I can define f inverse of x, alright, as x plus 2 over 3. Alright, and now if I take the composition of f inverse of x, okay, in other words, if I plug my inverse function into f, alright, I should end up with x. So I'm going to go to my f function. Wherever I have an x, I'm going to plug in f inverse of x, or this whole thing here. Alright, so I've got 3 times x plus 2 over 3 subtract 2. All I did was go to my f function. Wherever I had x, which was here, I plugged in my inverse, which was x plus 2 over 3. So it ended up being here. Now I can see that my 3's cancel. I'm left with x plus 2 minus 2, or I'm equal to x, which by definition of inverse should happen. Next, I can calculate f inverse composed of f of x. What this says is I'm going to go to my inverse function, which is here, and wherever I have an x, I'm going to plug in my f of x. So I'm going to my inverse function, so this is going to be equal to, well, I have an x right here, so I'm going to plug in f of x, 3x minus 2. Then I've got a plus 2 divided by 3. Okay. If I do my math, the minus 2 and the 2 go away, I'm left with 3x over 3, or this equals x. Just want to reiterate how I did this. Okay, I went to my f inverse function wherever I had an x, which was here. I plugged in f of x. So in place of this x here, I plugged in the whole f of x, which was 3x minus 2. All right. Then I had a plus 2 and a 3 divided by 3. Similarly here, I went to my f function. All right, wherever I had an x, which was here, I plugged in my inverse function, which was here, x plus 2 divided by 3. And by definition, when I evaluate these, I should always end up with just an x. I will work the second problem in the next video.